I'm going to be describing a concept that is pretty old. It's about how numbers came about. A long time ago, they had to describe and count things like how many houses were in the village and other sorts of things that we needed numbers for, but they didn't know how to do it. So they had to take count of the things that they had and take it to the supervisor who would be managing all of that. So we look at things like how numbers came about. For example, if one person would come, that would be 1, another would be 2, then 3, and so on. We're looking at how that came about. So this would be in regards to natural numbers, not things like decimals, integers, etc. It's about 1, 2, 3, and so on. So we're looking at 1, 2, 3, as big as they can go, and how you would count it. How did the number 0 come about? Nothing. That's what we're going to look at too. So a long time ago, say there was a house that no one lived in, there would be 0 people in that house. And so we would have 0, 1, 2, 3, and so on. So when 0 was added to that mix, natural numbers became whole numbers. So on a number line going from 0 to the right, you have 0, 1, 2, 3, 4, etc. On the left, on the opposite, what is that? How can you have something less than 0? So on that same number line, the exact same distance that 1 is from 0 on the right, on the left we have -1. That's going to be smaller. From the same distance that 3 is to 0, we have -3. All the way, -10 and 10, they're the same distance from 0, but they're in opposite directions on the number line. So again, 0 is in the middle of the number line. On the right are going to be positive numbers, 1, 2, 3, and so forth. On the left is going to be negative numbers, -1, -2, -3, and so forth. On the right, with these positive numbers, they're going to be really big. And on the left, with negative numbers, they're going to be really small. So on this whole number line, we started from 1 to infinity being natural numbers. When we added 0, we had whole numbers. And now that we're adding negative numbers, we have integers. So that is negative infinity, including 0, to positive infinity. So integers, in this case, can be positive or negative. As years and years went by, we took a look at this number line and we realized that we could break it down even further. We realized that between 0 and 1, there were even more numbers. So for example, if you were to divide in the middle between 0 and 1, you would have a half. And break that down even further, a fourth, and so on, getting smaller and smaller in between 0 and 1. Now again, we had natural numbers, 1 and on. Add 0, we have whole numbers. Negative infinity to positive infinity, we have integers. And now, adding numbers in between 0 and 1, any number that's not a whole number would be a rational number. So these rational numbers can be big or small. They're between 0 and 1, but they will never reach 0 and 1. So for example, getting smaller, you have 1/2 to 1/4, 1/4 to 1/16, 1/16 to 1/32, and so on. That's getting smaller, closer to 0. But getting bigger, from 0 to 1, you have 1/2, 3/4, and so on, getting bigger and closer to 1. But again, they will never touch 1. So again, as time went on, we labeled this rational numbers. So, again, this process on the number line, if you have 1 to infinity, all positive, all big numbers, that's going to be a natural number. When you add 0, it's going to be a whole number. When you add negative numbers, that's going to be a integer. And then when you add numbers in between 1 and 0, anything like a fraction or a decimal, that's going to be a rational number. Just like integers can be positive or negative, so can rational numbers. We have negative fractions, we have negative decimals, but also we have numbers that can be reduced or bigger. So you have a half, 1/2. 2/4 would be equivalent, but that's a different number. It would be smaller.